All right, if you remember the mole map, and I hope you do, and if you have it, you might want to get it out. Remember that we could go from mass of a substance and using molar mass, calculation of the molar mass, and using that as a fraction, calculate the moles of a substance. We have the moles of a substance, one substance, with a balanced chemical equation. We can get a mole ratio and get the moles of the second substance. And then from the moles of the second substance, we could calculate the mass of some product. We didn't spend a lot of time with these branches over here, but we did some math with it. We can go from the number of molecules to moles of a substance using Avogadro's number, or using this value here, 22.4 liters of any gas. We go from the volume of gas of a substance, the moles of the substance, and then through a balanced equation, you can get moles of substance B and get particles or mass or the volume of substance B. And that's the way this mole map was set up in unit, I believe it was 6. Well, now we're going to find out there's actually a fourth branch. If you call these 3 branches here, there's actually a fourth branch we can use on each one of these. And that's how you can get from the molar concentration and of course you know that song? You know that? Famous show, Mr. Ed. Okay. So let's just so we can go from something called molar concentration, which we're going to start looking at today, to moles. So we can plug in a fourth branch along the mole map here. And to go from molar concentration to moles, we have to just simply know the liquid volume of the substance to get from there to there. And that's our fourth branch. What we're going to do today is to learn about molar concentration. What is molar concentration? Well, let's talk about the term first. Molar concentration. We can also use the term molarity. And so if we say something is 1 molar, that means it has a molarity of 1. If it has a molar concentration of 0.5, we'd call that 1 molar. And we could also say it has a molarity of 0.5. So how do we get that? Well, to get molar concentration, we need to know the moles of some substance that's dissolved. And most of the time in high school chemistry, it's going to be dissolved in water. Moles of substance dissolved over the liters of the solution. So let's further define what solution means, just to be clear. A solution is both the stuff that you dissolve and the part of the solution that does the dissolving. If I'm dissolving sugar in water, the thing that gets dissolved is the sugar. The thing that does the dissolving is the water. And there's a word for that too. Solutions are made up of both the solute, and the solute is the part that gets dissolved, and the solvent, and the solvent is the part of a solution that does the dissolving. And then 9 times out of 10 in high school chemistry, the part that does the dissolving is going to be water. So let's look at a solution and see if we can figure out what would the molarity be. Let's say we're starting with 1 gram of sodium chloride in 1 liter of water. We're going to first have to find the molar mass of the sodium chloride in order to get it into moles. Remember, to convert from grams to moles, you've got to use molar mass. So here's our sodium and here's our chlorine. Get our periodic table out and find the atomic mass of both the sodium and the chlorine. And the atomic mass of sodium is 22.989769. And we only have one of those in the formula. And the molar mass, or the atomic mass of chlorine, is 35.453. We only have one of those in the formula. And so we're going to add then, take the sum of all the atomic masses of all the atoms in the formula, 22.989769 plus the 35.453, the sum of all the atomic masses of all the atoms in the formula. (22.989769) plus 35.453, and we get 58.419769. We have 3 empty slots over here on the right side, so we have 3 digits we have to round off, and we get a molar mass of 58.420. That 7 makes the 9 round up to a 10. I have a 0 here and a carryover of 1. That makes that a 2. So there's a 2, and that's the 0. And that's grams. Actually, this is also grams of sodium chloride. Grams of sodium chloride, and that's equal to 1 mole. The definition of molar mass is the mass of 1 mole of a substance. And this is the way we write it in this class. We always have, when we finish calculating molar mass, we always have an equality statement. So then, if we have 1 gram of NaCl, we can convert that into moles, and we need it into moles. Up here we need moles of a substance dissolved. By putting this over 1, using this equality statement to build a conversion unit, we're going to put grams of NaCl on the bottom, 58.420 grams of NaCl, 1 mole NaCl on the top. That allows us to cancel, much in the same way you cancel x's and y's in algebra, the grams and the species sodium chloride. And then we simply need to put the moles that we're going to have from this calculation over the liters of solution. We're putting it in 1 liter of water. We really need to know how the 1 gram of sodium chloride changes the volume of the solution here. So let's make an assumption to make our math easier. Let's just assume for this case we have 1 liter of aqueous solution instead of water, okay? AQUEOUS, which means a water-based solution. So 1 liter of solution. So now we're going to put moles over liters. So we need the liters on the bottom here. 1.00 liters of this NaCl solution because we're dissolving the NaCl in the solution. Okay, so we're putting just on the bottom. Okay, I could have put the liters of solution over here, would have given us the same answer. But let's do the math now. We got 1.00, and multiplying times 1 just gives us the same number. So we'll take that 1.00 and divide it by 58.420. And hit equals, and I get this number here. That's our molar concentration. So 0.017117426. Let's see. What we have left are moles NaCl over liters of NaCl solution. SOLN is a shorthand for solution. We look at our measured or calculated numbers. This one has 3 digits. This one has 5 digits. This one has 3. So all the measured and calculated numbers, the one with the least digits, are both of these right here. This one, the first one, and the last one. So I want our final answer to have 3 significant digits. Leading zeros are not significant, so this 1 here is our first significant digit. 1, 2, 3. These digits are all insignificant. So we're going to round this number off. Now we could write this, and that's perfectly okay. But it turns out that moles of a solute over liters of that solution, moles of a solute dissolved over liters of that solution, is the molar concentration. And there's a symbol we use. A capital M with a line under it. Okay? So instead of writing all of this, we can't just say it's molar sodium chloride solution. Okay? And that's the way that you calculate the molarity or the molar concentration of a solution. So, for practice now, you may work with a learning partner. Let's find the molar concentration of a solution in which 2.50 grams of hydrobromic acid is dissolved in 5.00 liters of aqueous solution. And then for homework, at least the first homework problem, find the molar concentration of a solution in which 7.25 grams of hydrofluoric acid is dissolved in 20.00 liters of aqueous solution. Okay, so the actual answer, as I've calculated, if I haven't made any mistakes, is 0.00618 molar HBr solution, or hydrobromic acid solution. The solution calculations look like this. You start with a 2.50 grams of HBr. You find the molar mass of hydrobromic acid, which is 80.911 grams HBr, which you set equal to 1 mole of HBr. Build your molar mass ratio here to get to moles. Cancel grams of HBr. And then you put that over the volume of the solution, which is 5 liters. And when you do the math properly, this divided by this, hit equals on your calculator, then hit divide by this, and equals again to get this answer. And you should get this solution.